Yeah, so for the function to be increasing, the condition is your f dash x is greater than 0.
So that should just be 1.
That is x raised to minus 1.
No, like 1 plus.
So increasing function, so your f dash x is greater than 0. So I'll find f dash x. So I'll u is equal to x square, v is equal to 1 plus x. So I'll apply the quotient rule. U dash is 2x, v dash is 1. Okay. So your f dash x is v into u dash. So 2x into 1 plus x, yeah, which is minus, yeah, correct, you are right. Perfect, you've done, huh? Minus x square, correct, upon b square. That's it. So that is, if you simplify it, what will it become? 2x plus x square, because this will become 2x square.
X square plus 2x plus 1.
Yeah, now generally, denominator don't expand. Even if you expand, no harm.
Yeah.
Generally, don't expand and waste your time. Now, what you have to do is you have to solve this, make it greater than 0 and solve. Because for an increasing function, this is the condition. So whenever the function is increasing, yeah, you can put it on solvent, or if you're doing it with the adjunct, you can put in solvent, but solvent won't give you greater than 0. So what you need to do is, basically when you cross multiply, so x square plus 2x is greater than 0. So you can graph x square plus 2x, and you can see when is it greater than 0. So if you graph x square plus 2x, your graph will come like this. The roots will be 0 and minus 2 basically. Now we want when this function is greater than 0.
When it's greater than 0.
So for what values of x is the function above the x-axis?
Yeah. So then greater than minus 2, less than minus 2, or greater than 0.
Correct? So these are my constants which were to be determined. So your x is less than b, so means my b is equal to minus 2, and x is greater than a, that means your a is equal to 0. Now this is a very simple sum in which you have to find dp by dn. So you apply the, as you correctly did, you apply the quotient rule. Okay, so derivative of 4 is 0, derivative of v, denominator is v, and you apply the chain rule.
Yeah.
So derivative of 1 is 0, derivative of 3 is 3 itself. I mean, because it's a multiple, you leave it as 3. E raised to minus n is minus e raised to minus n into minus 1. Chain rule. Because derivative of minus n is minus 1. And then you apply v into u dash minus u into v dash divided by v square. Correct? Now you can say that you have to say that, find an expression and explain why this predicts that the population is always growing. So we can say the numerator is always positive, because if you have graph of 12 e raised to minus n, this graph is always positive. Yeah. And the denominator, because it's a perfect square, is always positive. So positive upon positive is always positive. Correct? Yeah. Therefore dp by dn is always positive. Now whenever derivative is positive, means the population is always increasing. And this is simple. Find initial population. You put initial your n is 0. Initial population growth rate. Whenever say the growth rate, you have to put in the derivative.
Yeah.
Remember, derivative is always rate of change.
Yeah.
So you put n is equal to 0 in a derivative. This is the expression that you got. You can put in that. You can also use your calculator to do this. You know that. Run mode. Okay, and you get 0.75. What is the value of p as your n goes to infinity?
The limit that it approaches.
Correct. It will approach 4. You remember that's the limiting population. Yeah. This is logistic growth model.
Yes.
Correct? Yeah. And then sketch it. So to use your calculator, just sketch.
And then 4. And then 1 is the horizontal.
4 is the horizontal, numerator. Population is 4 is your horizontal decimal. It will be an S-shaped curve like this. If you sketch it now.
No, sir, I remember one thing, the asymptote being 4 over.
Ah, yeah, horizontal, 4 over 1.
So it's 4 over 1 plus 3. Oh, no, just 4.
No, 4. Because as your e raised to minus n, this will become 0. Yeah. 3 into 0. Or you graph it. You'll get a logistic model like this, basically. So I'm doing 1b, 1a is already done. So let me explain you 1a also. You've been given y is equal to x cube. Find out dy by dt when x is equal to 1 and when dx by dt is minus 1. You can clearly see here y is equal to x cube means y is a function of x.
Yeah.
So you differentiate it dy by dx.
Yeah.
So that will become what? 3x squared. Now this is important. This is your formula that you need to remember. You want to find out dy by dt. So dy by dt is dy by dx into dx by dt. So in your mind you can just, don't cancel it. You can see that, listen.
Yeah.
This is like cancelling out basically. So now your dy by dx, we already got it from here. Correct?
Yeah.
Dx by dt, your dx by dt is given to you, -1. And at what value of x you have to put it? 1. So put that x is 1 and that's your dy by dt. There's one more way of doing it. One more way of doing it, method 2.
This is substitution.
This is using this formula. This is actually a chain rule formula that we have applied.
Yeah.
Now method 2 is what you do is if y is equal to x cube, no, you differentiate both the sides with respect to x, with respect to t, using chain rule. So what is derivative of y? Dy by dt.
3x.
What is derivative of x cube?
3x.
3x square into dx by dt. Chain rule. Because that's not t, no? So into dx by dt. And then you substitute. So we are finding dy by dt. 3. What is the value of x?
I didn't get that. Why did you do 3x square into dx by dt?
Chain rule, no? Like suppose if I give you what is derivative of 2x plus 3 cube.
Oh, the inner function.
Inner function is your x. So outer function, inner function is x. Right. And the thing is we differentiate respect to t.
Yeah.
See, if we do respect to x, then it will be dx upon dx. So these are the two methods in which you can approach.
Okay.
Either you can do method 1, in which you find dy by dx and then apply the formula, or directly you differentiate with respect to time. I prefer method 2 because it's much faster. But don't forget the chain rule. So try 1b. Let me do this using method 2. You've done using method 1. Let me show you method 2. So 1b, y is equal to. So tell me what will it be. Suppose you differentiate with respect to t. So what will this become? Dy by dt. What is derivative of x square? 2x into dx by dt plus derivative of x is dx by dt. Substitute. You're finding dy by dt. You're putting x as 0. Your dx by dt is 4 plus dx by dt is 4. So 0 plus 4, so that's 4. That's it. See, you need to remember whenever y is equal to e raised to some function, the derivative is derivative of e raised to fx into the derivative of this inner function, which is your fx.
Yeah.
So if you have p is equal to e raised to q, now your
so it will just be e raised to q.
Yeah, it will be e raised to q, correct?
Yeah.
Into dq by dq, which is 1.
Yeah.
If you apply the chain rule.
Oh, you're saying that.
If you apply,
Oh,
yeah.
Okay, yeah, that I got.
Correct. Now what do you want?
Now I need to find.
You need to find a rate of increase of p. Means you have to find out dp by dt.
dp by dt.
So remember, rate means with respect to time.
So that you have to do e raised to
dp by dq
into 7.
into dq by.
So 7
dt.
E raised to 1. So 7.
7, yeah, e and q is 1.
7 is
7 is your answer. Let me do 4b using method 2. So in method 2, what will I do?
I did 4b.
Yeah, 4b. I'm doing method 2 now. We did method 1. So what you do in method 2 is you differentiate with respect to time directly.
Yeah.
So this will become dy by dt. Derivative of ln x is 1 over into
what?
No, now not 1. Now dx by dt. Because you are differential with respect to time now.
Yeah.
Okay. Now you substitute. Now the find the rate of increase of y when x is equal to 1. Okay. Now what you do in this case is, now this when x is 1, and x is decreasing at a rate.
So there will have to be minus.
Minus, correct. Very good, perfect. So this is, you put your x as 1, so 1 over 2, and is decreasing at a rate of 3, so minus 1.5 per hour.